A few days ago, Ark Invest had their Big Idea Summit, and with that, they published a 130 plus page PDF file. Today, I want to look at artificial intelligence and ride hailing as two of the major areas that they discussed. I think these have huge implications, and it's really important for all of us to look at that. Let's take a look. And for those of you interested in investing, check out WeBull, an amazing platform for buying and selling stocks, and now cryptocurrencies like Bitcoin, Dogecoin, and others. Open an account and get a free stock valued at up to $200, and fund your account and get another free stock valued at up to $1,600. Check out the link in the description and help the channel at the same time. Hey y'all, it's Dr. Know-It-All. So here is the Big Ideas PDF file that went along with their Big Ideas conference. It's chock full of incredible research and information. I will put a link, of course, to the summit itself and also to this document in the description so you can go check it out on your own. Anyway, I just want to touch on two areas. I mean, they talk about cryptocurrency, they talk about gene splicing, they talk about on and on and on and on. But I just want to talk about a couple things. I also want to make a note here that I'm not going to focus on this is definitely an investment portfolio thing, right? I mean, that's what Ark Invest does. They're an investment company, but I'm really going to focus more on the technology. There's a bunch of other people. Dave Lee has done it. Stephen Mark Ryan has talked about it. Rob Mauer's talked about it. TMIO Tesla has talked about it. So anyway, there's a bunch of other people who've kind of focused on this from more the financial aspect of things, but I really want to look at what they're talking about as the technology and what we can think about, I guess, almost in a societal manner. So anyway, this is their, first page about this. The training costs are declining at more than twice the rate of Moore's law. If you're not familiar with Moore's law, that's the law that Moore, one of the founders of Intel, came up with back in the 60s, that we would double the number of transistors on a chip every 18 months or so. It's been a little funky because we've basically been going to multi-processors, but essentially it's been holding true. But what they're saying here is that it's twice that fast. We're actually seeing it going faster. They're using Wright's law to model all of this stuff. And if you haven't seen my episode on Wright's law, you should definitely check that out. Go look at it in the card, or I'll put it at the end of this video so you can check it out. But Wright's law is super important to understand for how they're modeling all of this stuff. The other main bullet point on this page is that they're going to automate the tasks of knowledge workers. So AI has been thought about doing kind of like, when we think about like the robotaxi, for example, that Tesla's got, that initial job that it's going to do is going to be working in a factory doing relatively straightforward tasks like moving boxes, screwing bolts into, nuts into bolts, etc. But eventually AI's goal is sort of to take over knowledge workers, which are people who are doing more, not necessarily creative work, but at least things like accounting, office administration work, paralegal work, et cetera, et cetera. So there's a lot of things that AI can do that are more sort of, mentally, I guess, challenging than just doing standard things like robots on an assembly line. All right, so let's take a look at the individual pages of this. So page number 1, they actually show how they have modeled Moore's law versus Wright's law, and how Wright's law is more accurate in terms of the way that they're going. They've got 2015, 2020, that's their data points so far, and then they're modeling out 2025 and 2030, of course. The black line is Moore's law, and you can see how relatively slowly things are reducing, whereas they're reducing much more quickly using their Wright's law forecast. Of note, they've got GPT-3, which they estimate, you couldn't have done this really in 2015, but they estimate that it would have cost somewhere around $875 million to run a network that size in 2015. It cost about $4.6 million to do it in 2020. And they're saying, according to their research, that it's going to be down to $500 in 2030. GPT-3 is an amazingly huge neural network with 170 billion parameters. I believe James Dema said that that was the correct number of parameters. Anyway, check out our chat. It's an amazing chat. Me and James we go into a lot of stuff, but we actually talk about GPT-3 as part of our discussion. So anyway, you should definitely check that out. But you can see a kind of almost like a cliff, the way that the cost of doing this research is falling. And then the really crazy part is this next paragraph down here. The human brain has approximately 240 trillion synapses. If it were able to be modeled now in 2022, 2021, it's not, we can't do that yet. But if it could, they've estimated it would cost $2.5 billion to train a network modeled on the human brain. But that by 2030, it would drop to $600,000, which is just a drop in the bucket for larger companies. So That's kind of a scary thought, actually. It means that we could be at a state, if their forecasts are true, where we could model a human brain, something equivalent to what's going on up here, for less than $1 million by 2030. I don't personally know if that's possible. The human brain is very complex, very highly parallelized. But you know, they're making a pretty bold claim here, and if it's true, and we will find out in not that long, because you know, in order to get to that $600,000 mark, they're going to have to be able to do modeling of things for, let's say, 40 or 50 million dollars by like 2026, 2027. So it's not going to take that long to see if we're actually headed that direction, and if we are, wow, I mean, AGI could be coming faster than people think, because that's about the part where you have something complex enough to actually start to think about being a general intelligence. This next slide is really interesting. It shows they've got the actual cost per unit for both hardware and software, which is interesting. They call it the AI RCU, or relative compute unit. Anyway, they've designed this study, and what they're looking at is real data points here, and then which is the black, which models pretty darn close to this line, and then projecting a linear line down to, and Wright's law, of course, is all based on doublings of production. So you can see they've got 1 unit of production here. By the time they get to 100 or 100, things have gone down quite a bit. It actually looks steeper in the software version than the hardware version, but I think the hardware version might actually be steeper, because this is modeled out to 1 million units. This is modeled out to 100,000. Anyway, it's showing there's a drastic decline in the compute cost, both in terms of hardware and software. So that's pretty impressive. The next slide shows productivity boost. So they're not really saying replacing workers, but in a way they're kind of talking about that. So what they're meaning is that the individuals who work in an environment can produce more work than people can do today, which of course means that companies could choose to reduce workers in those areas, or they could just produce more product in those areas. Anyway, software developer 2x, right? So that's pretty impressive. I'm already seeing that. Code completion tools and things like that that are starting to be powered by AI right now are really impressive. You can see accountants, they can improve production, bookkeepers, lawyers, which is really interesting. Paralegals who work in legal offices, that's a 4x, increase in productivity. And office and administration support, which is a lot of tedious grunt work, but that would be really impressive if you could replace 4 office workers, 4 admin workers by one of these AIs, or alternatively make these people 4 times as productive as they have been before. And just as an example of this, we have the OpenAI Codex, which can autocomplete 37% of coding tasks. And that's not coding tasks. Like right now, what I'm used to is I start typing in a Python command or something, and it autocompletes the end of that command. What this is talking about is something really different. Make a red ball bounce around the screen. It converts that into actual code here. That is really impressive stuff. You type it at the bottom, it does it at the top. If it's able to do that 37% of the time now, even if it's not perfect at this point, if it can get you pretty close, if you're a coder, that can get you a long way towards being able to code something up without having to do it yourself from scratch. And, take another couple of years from now, and we could be looking at 60, 70% completion of these kinds of tasks. And then by 2030, we could be looking at computing code that you can give it high-level instructions, and it can go ahead and do that task for you. Now, I don't think it's going to be able to completely do code from scratch. You won't be able to say, make me a neural network that can do code autocompletion. You can't give it that high of a level of task. But what we're talking about is, this is a lot of lines of code that it has to be able to figure out how to do and make work. And so it's very impressive that this OpenAI Codex can do this already with a 37%. That's a third accuracy, right? That's over a third accuracy. And if it can double that to 2/3 accuracy or more, that means that also people who are not really good coders can probably start to do code. They can generate code themselves by just typing something into the screen. So this is really impressive as an example of how much AI could improve productivity. All right, the next slide is a little bit scary. It actually shows that what you want to be in is in software development in the next decade, because it looks like software is going to get a 42% annual growth rate to $14 trillion by 2030. And also, if automation boosts productivity by 140%, AI software could increase the output of global knowledge workers at an annual rate of 9% to $97 trillion in 2030. So this is just kind of like, these are huge, huge numbers they're talking about here. So you can see here in the graph that we're currently around $1 trillion spend on software development and everything, and they're projecting by 2030 it's going to be 14 trillion. That's a 14x thing. So again, if you're looking at something to go into in the next decade or so, I highly recommend software development, and in particular AI. It looks like this is going to be a good place to be working in the next decade. There's going to be a lot of jobs that, people are going to be sucking down everybody who is trained in this area as fast as possible. And of course, looking at this, you can see the labor output increase from AI software is going to go up to somewhere around $56 trillion. So this is really incredible if you start looking at these numbers. These numbers are just mind-numbingly huge. And of course, with software comes hardware. They're always in pairs. It's like software demands more out of hardware, hardware increases, software gets better, software demands more out of hardware, hardware increases. So you can see the same sort of thing. We're looking at compute power is going to have to go very, very rapidly upward. And again, you can see here we're at $17 billion up to $1.7 trillion just in hardware. And a lot of that is AI compute, this darker purple color, and then we've got storage and network and overhead, which are communication devices and back-end stuff, all of that kind of thing. So anyway, all of this indicates that we're, again, if you're in hardware, there's a lot of room to grow in hardware, and hardware is going to increase. I'm going to do an episode soon as I get a chance to do this on neuromorphic chips. I think that's one of the areas that things are going to develop in. It looks like it's a really, really impressive area. One of the things that's really interesting about chips right now is that they're only starting to become good for neural networks and AI training and stuff. For the most part, the chips that we used were gaming chips for a long time. They were GPUs, made by NVIDIA and everybody that were built for gaming. They weren't really designed for AI work. So there's a lot of room to grow and a lot of room to improve the performance of all of this stuff. So that's what they're indicating here is that, even the hardware costs alone are going to increase by orders of magnitude here. Just real quickly, again, I'm not doing a financial analysis of all of this, but what they're modeling, the Ark consensus model for all of this by 2030 is somewhere around 20-something trillion dollars. But the market consensus is only a little over $5 trillion. So there's like a $15 trillion difference between what Ark is modeling and what the Wall Street analysts are. So basically, if you believe what Ark is saying, you should again get into this industry either as an investor or as a worker, because this is a huge gap. As an investor, this is the kind of gap that you really want to get involved in. If you believe this, if you believe their research and what they're saying, that's the kind of gap where you can make a lot of money. Again, not a financial analyst. I'm terrible at that kind of stuff. I'm just one guy talking about his opinion and just talking about what Ark Invest is saying. And you can even see down here, forecasts are inherently limited. So, don't go blaming me if you invest and it doesn't work out. I'm just telling you what their research is showing. And finally, the big takeaway here, artificial intelligence could scale from $2.5 trillion to $87 trillion by 2030. Right? So you've got AI hardware down here at the bottom, foundational AI model as service APIs, and then you've got AI applications. So my company is actually an AI application. Underneath things like that, you've got hardware, which is like AWS hardware. We're using Amazon Web Services hardware and so forth. And then there's foundational models as services, things like TensorFlow or PyTorch as software. And then of course, a bunch of hardware like, the Apple chips that are in these guys that have a lot of neural drivers in them and on my computer, and of course on rack servers and mainframes, et cetera, et cetera. So anyway, this is just a massive kind of thing. We're only looking at 9 years between 2021 and 2030. And to be able to jump up that much from $2.5 trillion to $87 trillion is ridiculous. So this is the kind of thing to be paying attention to. And again, because it's an exponential type ramp, it's not going to look like that much over the next couple of years, but it's going to go like that really, really fast. So be looking for this around 2025, 2026 is when you should really start seeing this stuff take off. All right, so let's turn to the second half of this, which is autonomous ride hailing. So I just want to touch on this a little bit less than AI as an overall thing, because this is actually a subsection of AI as a whole. But it is important enough, especially from Tesla's point of view and Tesla investors' point of view, that I think it's worth touching on this specifically. And obviously, Ark Invest agrees. So again, starting with the big takeaways, Autonomous ride-hailing will reduce the cost of mobility to 1/8 the average cost of ride-hailing today, spurring widespread adoption and unleashing unprecedented economic productivity. In other words, if you're spending less money on transportation, you have more money to spend on other things, so that's a good thing. And also here, Ark's research suggests that autonomous ride-hailing platforms will add roughly $26 trillion to the GDP and $2 trillion in profits alone per year by 2030. And just a little bit of perspective here, the global GDP was about $89 trillion in 2021. So think about these kinds of numbers. That's like around a third of the total GDP right now that will be added just by ride hailing if they're correct in these forecasts. So this slide is really rather interesting. It shows that it was rather expensive to have, this is all in adjusted dollars today, of course. It didn't cost an actual $1.70 back in 1871, but adjusted to 2020 dollars. You can see that, a horse and carriage cost about $1.70, but after the Model T was introduced in the 1930s, it's been flat. It's been right around 70 cents per mile overall, but that we could suddenly go from that, not quite a third, but down to 25 cents per mile by 2030, assuming that ride hailing and all of that stuff is not only accomplished by Tesla and other people. I think, again, Tesla is very much in the driver's seat for all of this, but also it has to be legally approved. But if it is, we could drop down to somewhere around a third of where we are right now in terms of per mile cost. So here in this slide, we look at the marginal cost. That's not the total cost. So again, the total cost of a vehicle is you have to pay for the car, but then you also have to drive the car. And currently just the driving the car part, the gasoline, the maintenance, all of that kind of stuff is about 34 cents a mile. Currently, ride-hailing services like Uber and stuff in the developed world are about $2 per mile as opposed to 34 cents. So it's much more expensive to take an Uber, but there's a convenience factor and there's also a perceived value of time with ride-hailing. So those two factors cause people to still use ride-hailing, even though it is way more than an individual car. Of course, there's also an aspect that I don't think they talked about as much, but that a lot of people are not in an economic situation where they can afford to purchase a car and own a car. Or maybe they don't have a driver's license, or maybe they can't get insurance, things like that. So there are, not great economic reasons for people to take things like Uber and ride-hailing services. And of course, for those people in particular, if the cost of this comes down drastically, that is a huge win for people who are in a class of folks who are unable to get a car and afford a car, but still need to transport themselves around and are currently, being screwed by having to pay a lot more money per mile to drive places. So real quickly, this graph shows the different markets and what people are willing to pay. So over at the left is like the Western world, the Western markets and things. And then you kind of go down, as you become more price sensitive in other countries and other areas of the world, you can see how the reducing cost of per mile travel will cause more and more people to opt for this type of transportation as opposed to other types of transportation. And there's a very, very long tail at the end of that. But an $11 trillion addressable market is a pretty impressively large market. This next slide is really, really bizarre. They actually are talking about the possibility of air travel, some sort of like little mini drone or something like that that could fly you around as being enabled by this type of thing. And I think part of that is that it's an autonomous air traffic, right? So it can fly you by itself without having to have a very expensive operator. You can see that for a 5-minute trip, a helicopter is $195, which is great if you're a super rich person, but not for regular people, right? But then what you can also see is that the longer you're willing to wait, so if you're willing to wait 60 minutes, you can take a New York City subway from Manhattan to the JFK airport. But on the other hand, you could get to the point where you could have an autonomous taxi, which can get you there in about 80 minutes. And remember, to go from the subway, you've got to get to the subway from your place in Manhattan. So that could add several minutes as well. And of course, a taxi is more convenient because you can throw your luggage in there and not have to be hauling it around the subway and everything. So a lot of people, if it's $2 more and 20 minutes more, will opt for autonomous, whereas these other options are fairly expensive. But the really interesting thing is this little drone flying thing, right? So if you're willing to pay $74, which is a lot less than half of a helicopter ride, you can get to the airport in 18 minutes in your little private drone. So kind of interesting. I have no idea if that will come true. Ark says that it's already beginning to happen. So I think that's really cool if it is. I don't know anything about it, but I'll keep an eye out for that. If it does look like it's becoming a real product, then I'll start to look into doing some videos on that. But that's a really cool little area. The next slide is really cool. So if you look at right now, the current enterprise value is all owned by automakers. So there's a small amount for ride hailing, there's a small amount for car rental. I mean, it's hundreds of billions of dollars, but it's, compared to 4.1 trillion, it's not that much. But what's going to happen is they're projecting by 2026, this is only 4 years from now, 5 years from now, at the end of that, that the autonomous platform provider is going to have a huge share of this, and that the vehicle makers are going to drop from 4.1 trillion down to only 1.6 trillion. And then, of course, fleet owners will kind of collect the ride-hailing / car rental parts of that. But basically, the autonomous platform provider, the ones like Tesla, who are providing the full self-driving and then also potentially building the cars as well, are going to gain the lion's share of this. So again, I'm not an investment advisor by any means whatsoever, but if you look at this, it looks like where you want to be investing, if you are thinking about investing, is towards the autonomous platform providing company. And of course, here we have the big takeaway. Autonomous ride hailing could have more economic impact than any innovation in history, adding roughly $26 trillion to global GDP by 2030. So again, graphic, you've got steam engines and how much economic impact they had. A tiny fraction of a percent. Robots from 1993 to 2007, the big factory robots and all that stuff, what we saw in the Terminator, all that, right? Maybe 0.5%. Internet technology in 1995 to 2005, maybe about 0.6%. And then you've got robotaxis could add about 2.8% to the global GDP by 2030. Just that by itself. That is a massive gain. So this is the kind of thing that artificial intelligence really enables. So, connecting up the first and the second half of what I'm talking about here, or what Ark Invest is talking about and I'm discussing, is that if you take AI and you put it together with robotics in particular, in just this one instance, you can create a massive economic opportunity. And AI has all sorts of other venues besides just ride hailing. So it really is a sea change. It's the kind of thing that can change the world in a way that we really kind of won't recognize what the world looks like when it gets done. And that could be happening by 2030. One little thing to look at real quick in this graphic is that there are people who lose. There's going to be medical revenue, property repair revenue. So again, cars, if there are less accidents, you don't have as much insurance and all of that kind of stuff. Maintenance revenue, fuel revenue, insurance revenue, personal car sales, etc. So those people are going to be the losers. So that's something to keep in mind. But what you've got is a massive, massive uptick in all of these other areas. So again, as a worker or somebody coming out of college or somebody who's thinking about careers, going into this area sure seems like a good idea. And in terms of being an investor, if you're thinking along those lines, again, it sure seems like Ark Invest is saying that this is a good idea. They are way, way, way more bullish than Wall Street is. But if you look at the past, Ark Invest has really been on it in terms of these disruptive technology trends. So anyway, there's an awful lot of stuff to think about here, but the important takeaway is AI, if it keeps growing at the pace it has been, and it keeps using Wright's Law, and it keeps flowing, and it keeps getting cheaper, and you're able to do more compute, by 2030, the world's going to be almost unrecognizable from what it is today. This is just 8 years from now. So keep that in mind, keep an eye open. And I, for one, am really excited about following along with this, having conversations with all of you, doing these videos for the next 8 years, and seeing where things go. All right, I hope you enjoyed this episode and found it a little bit, mind-expanding and fun and interesting. If you did, please do like the video so other people can find it, because YouTube's AI works that way. And also consider subscribing for more of this content. As always, a huge shout out to my patrons on Patreon. Thank you all so much for your support. If you want to join the team, definitely check out the link in the description. And if you're interested in some awesome merch, check out the link in the description. We've got the Tesla Bot t-shirt, which is super popular these days. Don't mess with Tesla. Lots of other t-shirts, tumblers, mugs, etc. So check out the link in the description and help the channel out. And for those of you interested in investing, check out WeBull, an amazing platform for buying and selling stocks, and now cryptocurrencies like Bitcoin, Dogecoin, and others. Open an account and get a free stock valued at up to $200, and fund your account and get another free stock valued at up to $1,600. Check out the link in the description and help the channel at the same time. Thank you. And finally, don't forget we are both Tesla and Amazon affiliates. If you look in the description, you can see how going shopping for a solar roof, a Powerwall, or anything on Amazon helps out the channel. In the meantime, I'll see you in the next one. Bye-bye.